All right, we're wanting to find the area bounded by y equals sine x and the x-axis rotated around the line y equals 2 pi. All right, for this, we're just going to set this one up because it turns out the integral we're going to get is something we're not going to learn how to do until we get into chapter 7. So let's just set this up. You get y equals sine x and the x-axis. And I didn't say, but let's say from 0 to pi. So we've got this area here. And I want to rotate that around the line y equals 2 pi. All right, so that's pi, it's 2 pi. Now, some people are tempted to draw the other part right here, but that's not right. What we're doing is we're taking this, this whole area over here and rotating it around this. So if you were to draw in a line here, this is going to swing over to 3 pi, and this is going to swing over to 4 pi. So those things, they should be exactly the same, although my drawing's not great. And then we're going to draw a shell in the middle. This thing is going to look like that. And let's see the radius. Well, we need two things. We need the radius and the height. The radius is the length of that. And the height is the length of this. All right, let's label all these points. This point here is the point, well, let's see, it's x sine x. This point here is x coordinate x, y coordinate 0. And this point is x coordinate 2 pi, y coordinate 0. All right, so the radius is the distance from this point to this point, and so that's going to be the difference in their x values. So the radius is going to be 2 pi minus x. And the height is the length of this line, and so that's the difference in its in the y coordinate here and here. So that's going to be sine x minus 0, or just sine x. So our volume is going to be 2 pi integral radius, height, thickness. Thickness is dx. All right, now our endpoints always go from one side of the area to the other. So that's going to be from 0 to pi. And this is an integral that we don't know how to do yet. Turns out, well, what we could do is we could distribute that sine x over these parentheses here, and we get 2 pi sine x. We could integrate that, but we'd also get minus x sine x, and that requires integration by parts, and we'll learn how to do that in chapter 7. But let's put this on the calculator and see what we get. Actually, I want to do two things with this. Desmos, I'm just going to type this in. We got 2 pi times integral from 0 to pi of 2 pi minus x sine x dx. And let's see. I'm going to go back in and put in some parentheses just because, yeah, because it's 59.21. So that's just evaluating the integral numerically. If we go over here and plot this, let's see, what do we have? We had sine x. And this is a little picky. I have to put in sine parentheses x. 0. We're going to rotate around x equals 0. And we're going from 0 to pi. So if I shade the area, it's not wanting, oh, there it is, shade the area. And if I rotate it now, oh wait, that's not the right place to rotate it around. We want to rotate it around the line x equals 2 pi. So when I enter that in, notice the puts my axis there, and I'm going to rotate it, and we get this big thing. I need to optimize this for size for the image. Let's see, what's the volume? 59.4. What's that compared to? 59.2. Let's give it 100 shells. 59.22. Yeah, that's pretty good. Just for fun, let's zoom in and look at an individual shell. If I turn the opacity way down, let's see, the shells are kind of hard to see. You know, the graphics are not working quite right. I'm going to turn the opacity all the way down. And well, you can kind of see part of the shell there. All right. So I want to do a bunch more examples, but I'm probably going to do mostly just one example per video. So we'll stop here.